Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from definite integrals involving greatest integer function, right? So here we have to find the value of this integral from 1 to e raised to 6, and here the integrand is greatest integer function of log x divided by 3, right? So here we can solve this integral either by two methods. The first one is the method of inequalities, right? So by making use of the concept of inequalities, we can solve this integral. Or the second method is the method of substitution, right? So we have already solved these type of problems in our earlier videos by method of inequalities, right? So in this lecture we'll solve this integral by method of substitution, right? So let us start, and let us first call this integral as I. So here the integrand is a greatest integer function, right? And here we have log x divided by 3, right? And the lower limit is 1 and the upper limit is e raised to 6, where e is the exponential number, right? And here the log function, that is log of x, is the natural log, right? We can also write ln for log of x, because here the base e is understood, right? So we'll simply write log x for log x to the base e, right? We can also use the notation ln for log x, right? Okay, now see here we'll take the substitution, that is u is equal to log x divided by 3, right? So here we'll introduce a variable u, that is equal to log x divided by 3. So now from this equation we can write log of x is equal to 3u, right? And by definition of log, we can write x is equal to e raised to 3u, right? So the relation between x and u is either given by this or by x is equal to e raised to 3u, right? So these two statements are equivalent, right? Okay, now let us differentiate both sides with respect to x, right? So we have du over dx is equal to 1 over 3. The derivative of log x is 1 over x, right? And from here x is e raised to 3u, so we have 3 times e raised to 3u. So now we can write dx is equal to 3 times e raised to 3u, and here we have du, right? Now we know that whenever we solve definite integrals, we always change the limits when we make use of the method of substitution, right? So here x varies from 1 to x is equal to e raised to 6, right? So here we can write x is equal to 1. So when x is 1, we have u is equal to log of 1 divided by 3. So log of 1 is 0, that is 0 over 3, that is 0, right? And when x is equal to e raised to 6, then the value of u can be obtained as log of x. X is e raised to 6, and here we have 3, right? So from here we can use the property of log, that is log a raised to b is b log a, right? So here we have 6 log e divided by 3, and we know that log of e to the base e is 1, right? So here we have 6 times 1 over 3, so u is 3 to the 6, so here we have 2. So finally we have uh, x is equal to 1, so u is 0, and when x is e raised to 6, then u is 2, right? So now our variable u varies from 0 to 2. So now we can write I as u is equal to 0 to 2, and here we have greatest integer of log x over 3, which is equal to u. And for dx, we can write 3 e raised to 3u and du, right? So now our aim is to find out the value of this integral. So let us rewrite this integral I as taking 3 outside the integral. We have 3, then we have 0 to 2, and here we have greatest integer of u and e raised to 3u du, right? So the limits of integration vary from 0 to 2, and here we have the greatest integer of u, right? And see, whenever we come across with greatest integer function, our prime objective is to search for integers, right? So always remember, whenever we come across with greatest integer function, we always go for the integers. So between 0 and 2, we have the integer 1, right? So we'll split this integral as a sum of two integrals, right? So the first one goes from 0 to 1, the second one goes from 1 to 2, right? So I can be written as 3, and here we can use the brackets. So the first integral goes from 0 to 1, and we have greatest integer of u e raised to 3u du, right? And the second one is from 1 to 2, right? And here we have greatest integer of u e raised to 3u, and here we have du, right? So now we have to solve these two integrals, right? Now see, we'll take these two integrals one by one. So let us first take this one. So here in the first integral, the value of u, it varies from 0 to 1, right? So it varies from 0 to 1. So whenever u lies between 0 and 1, then the greatest integer of u should be equal to 0, right? So this is the definition of greatest integer function. So when u lies between the integers 0 and 1, then the greatest integer of u must be equal to 0, right? So this is quite simple. And here u goes from 1 to 2, right? And when u lies between the integers 1 and 2, then the greatest integer of u must be equal to 1. And this is again due to the definition of greatest integer function, right? So now here for greatest integer of u, we can take 0, and here for greatest integer of u, we can take 1, right? So obviously this integral, that is the first one, it disappears, right? So the value of this integral becomes 0, because here greatest integer of u is 0, right? And see, here we have 1 to 2, and for greatest integer of u, we can write 1. So here we have 1 e raised to 3u and du, right? So now we can write I, and here we have 3, and 1 to 2 e raised to 3u du, right? Now we know that the integral of e raised to x is e raised to x, or in other words, we can say that the integral of e raised to mx dx is equal to e raised to mx divided by n, right? Where n is some real number, right? So here we have e raised to 3u divided by 3, and the limits of integration are from 1 to 2. So now here this 3 and this 3 get cancelled. So we have I is equal to e raised to 3u, and limits of integration are from 1 to 2. Now we can simply substitute the limits, and we'll take the difference. So we have e raised to 3 times 2, that is 6, and here we have 3 times 1, right? So I is e raised to 6 minus e raised to 3, right? So this is the final value of this integral, right? So I is e raised to 6 minus e raised to 3, where this number e is our famous exponential number, right? So viewers, this is how we can deal with these type of integrals involving the greatest integer function.